Our next lesson is called Solving Systems of Equations Algebraically, Day 2. In example 1, why does the elimination method work? Solve the system of linear equations algebraically. And again, we are going to be investigating the elimination method. Okay, so our original system is 2x plus y equals 6 and x minus 3y equals negative 11. With elimination, it's exactly as it sounds. We want to eliminate one of the variables. So eliminate a variable. When you are trying to do this, what you're looking for is opposites. So we want to be able to take these two equations and add them together so that when we do so, one of the variables disappears. So you're looking for either the x or the y to have opposites in their coefficient so that when you add them, they cancel each other out and make 0. So if I look at this original system, 2x and x are not opposites, and 1y and negative 3y are also not opposites. However, I can see that if I take 2x plus y equals 6 and I multiply it by 3, that will give me a 3y, which will be opposite of my negative 3y. Now, very similarly, I could have decided to multiply the bottom equation by a negative 2, because that would give me 2x and negative 2x. When you do this, remember that you're using distributive property, and it must go to all of the pieces. So we end up with this new system. We end up with 6x plus 3y equals 18, and we have the same second equation, x minus 3y equals negative 11, that we had before. We're now going to add those together, and 6x and x make 7x, the y's disappear, and I have 7. So you can see by doing that, we have eliminated the y's, and we now have one equation with one variable that we can easily solve by dividing by 7 and getting x equals 1. Now, if you think about how this relates to solving systems graphically, which we've already done, when you solve a system graphically, you graph two lines, one for each equation, and the answer is where they cross. They cross at a coordinate, which means I need an x value and a y value. At this point, all I have is the x. So you have to go back and pick either equation you want to plug in your x value and find your y. So we'll say pick either equation to find the other variable. Okay, so it really doesn't matter which one. I'm going to pick x minus 3y equals negative 11. I already know x is 1, so I'll put 1 in x's place. And by doing that, I have one equation with one variable that I can now solve. I'm going to get rid of 1 by subtracting it. Negative 3y equals negative 12. And then I would divide both sides by negative 3. And I get that y equals 4. So now up here for my solution, in set notation, I list my coordinate as 1, 4. So you need parentheses around the 1 and 4 to show that it's a coordinate, which tells me x is 1 and y is 4. And then you need squiggle brackets around the entire thing to have that set notation. Now in example 2, they have very specific directions for us. It says create a new system of equations with the same solution as the original that eliminates variable y from one equation, then determine the solution. So in this particular situation, they're wanting us to very specifically eliminate y, which means that's the one I have to get rid of. So if I'm looking at my original system, 2x plus 3y equals 7, and x minus y equals 1, and I'm concentrating on my y's, I see that I have a 3 and a negative 1. So if I already have a 3y, it would be great if the other one was a negative 3y. I already have the negative, so I'm going to have to take this equation and multiply it by 3. Remember, it's distributive properties, so it goes through the entire thing. So my new system is the same first equation, 2x plus 3y equals 7. And underneath, my new equation is 3x. 3 times negative y would be negative 3y. And then 3 times 1 is 3. So now I can add these together. 2x and 3x makes 5x. My y's are eliminated, which is exactly what the directions wanted me to do. And I get 7 and 3 makes 10. So now I can divide both sides by 5 to get an answer of 2. Now remember, that's only part of my answer. We're going to pick either equation. I'm going to pick what I feel to be the easier one. X minus y equals 1. I already know x is 2, so I will replace that. And then I will solve this two-step equation by removing 2. So I have to subtract it from both sides. Now do not forget to bring down that negative. We have a negative y equals -1, which means there's really a -1 in front that we will be dividing by. So y equals 1. So for my solution, remember, squiggles, then write it as a coordinate, 2, 1, and end my squiggles. Now the next problem says, try it out. Okay, so I'd like you to pause the video and try out this question. It says, create a new system of equations with the same solution as the original that this time eliminates x. So they want you to do the same system, but instead of eliminating y, we're going to eliminate x this time to determine the solution. So pause the video and resume when you're ready to check. Okay, so if we want opposites and I have to get rid of x's, I see I have 2x and 1x. So I would like it to be 2 and -2 so that they're opposites. I would need to multiply this equation by a -2. So we're going to have to distribute to all of the pieces. I end up with the new system, 2x plus 3y equals 7, same first equation. My new second equation is -2x plus 2y equals -2. And now when I add them together, the x's are eliminated. I get 5y equals 5. Divide both sides by 5 and get that y equals 1. So now I have to go back and find x. So x minus y equals 1. Remember, you can pick either equation. I already know y is a 1. So I'd add 1 to both sides, and x equals 2. So my solution is an x value of 2 and a y value of 1. Now, is that coincidence? No, it is not. They are the same system. The only difference is that one of them you eliminated y and the other one you eliminated x. So these two should be exactly the same. It's the same system, just with a different process of which variable to eliminate. Again, this is if there has not been class practice given to you separately. So please complete questions 1 and 2, and then questions 3 and 4. Okay, you've had time to try these problems on your own, so we will go through the answers. For each of these, you need to determine the solution of the system by using the elimination method. If I'm looking at number 1, I already have opposites, positive y and negative y, so I can immediately just add these together, get 3x equals 4, divide both sides by 3, and get that x is 4/3. I can pick either equation I'd like, so I picked x plus y equals 2. I already know that x is 4/3. I will subtract 4/3 from both sides to get y alone, and I end up with 1/3. So now I know my solution is an x value of 4/3 and a y value of 1/3. In number 2, 3x minus 4y equals 26 and x plus 2y equals 2. I do not have any opposites, so I need to make opposites, and I decided to eliminate the y's by multiplying this equation by 2. That gave me the new system, 3x minus 4y equals 26, and then the new equation on the bottom, 2x plus 4y equals 4, and now I can add them together. I end up with 5x equals 30. I then divide by 5, and x is 6. I can pick either equation I'd like. I picked x plus 2y equals 2. I replaced x with 6. And now I solve this two-step equation. Subtract 6 from both sides. 2y equals -4. And then I would divide by 2 to see that y is -2. And now I know my solution is an x value of 6, a y value of -2. And I close those. Now remember, if I want to do a check, I can do that at any time. It's just that it has to check in both equations, so you should have 2 checks when you do that. Okay, and number 3, word problem. The sum of 2 numbers is 10, and their difference is 6. What are the numbers? Create a system of 2 linear equations to represent this problem. What is the solution to the system? So first we need some let statements. We have 2 numbers, so we'll let x equal the first number, and we'll have y equal the second number. So now we're working with 2 variables. So the sum of 2 numbers is 10, should be x plus y equals 10. The difference is 6, would be x minus y equals 6. I already have opposites in my y's. So if I add those together, I get 2x, the y's disappear, and I have 16. I would divide both sides by 2 and get x equals 8. I then have to go find the other number. So I did x plus y equals 10. I chose the first equation. I replaced my x with 8. And then I subtract 8 from both sides to see that y is 2. So now I know the numbers are 8 and 2. So if that was written as a coordinate, it would be 8, 2 with the squiggles around it. Okay, and then lastly, in number 4, verify that the ordered pair 2, 3 is the solution to the system. So what I'd like you to do here to this problem is add that you need 2 checks. You should be doing one for each equation. And if it's 2, 3, my x value is 2 and my y value is a 3. So my first equation, y equals 3 halves x. I'm putting a 3 in y's spot and a 2 in x's spot. 2 goes into 2 one time, so I get 3 equals 3. It checks. Then I have 2y equals negative x plus 6. So that's 2 times 3 equals negative 2 plus 6. And I get that 6 equals 4. Does that work? Nope. So I slash that. So this tells us 2, 3 is not a solution. So what we know is that it must check in both. And that concludes our lesson on solving systems algebraically, day 2.